File systems are emerging as the foundational abstraction for AI agents. When agents have access to a file system, they can manage context, reason across documents, and also generate new artifacts in a very structured way. But local file systems can also be limited, personal, ungoverned, and also disconnected from collaborative workflows. In this video, I'm going to show you how you can back a virtual file system with Box using LangChain's Deep Agents SDK, and why that matters for real-world AI systems. I'm Andrew, Senior Developer Advocate here at Box. Let's check it out. Now, this demo builds on a great Deep Agents example from Christian Broman at LangChain. In his demo, the agent sees a single virtual file system. Under the hood, it's backed by multiple systems like cloud storage, SQLite, and local disk. In the original demo, the agent calls list, read file, and write file. It doesn't know where the data actually lives. So, in our fork of the demo, we keep the same pattern, but we replace the cloud storage layer with Box. And that abstraction is the key. Now, the question becomes, what happens when you replace a cloud storage layer with something enterprise ready? If you look at the Box API, it already maps really cleanly to file system operations. So this set point would be directory listing. This one would be reading a file. We also have creating a file. And on top of that, we can upload a new version of the file as well. So along with content, you can think of Box as a secure, governed file system backing your agent's context. The agent still sees folders, but now those folders are backed by Box. Let's jump over the cursor and check it out. This is the core architecture. Deep Agents routes file system paths by prefix. /workspace is local output. /memories is SQLite virtual files. And /docs is Box. Next, we authenticate with a Box developer token, scope everything to a single folder in Box. Then we warm a cache, so path resolution is fast. And after this, /docs is effectively a Box-backed file system. At runtime, everything reduces to simple file system operations. You have list, read, and write. Let's check out one of them. Here, the agent calls read file. The backend resolves a path to a single Box ID, then downloads the content and returns it. It also formats with line numbers so the agent can actually reference specific lines. Now, let's check out what happens when the agent writes a file. In short, if the file already exists, we just upload a new version. That means agent-generated outputs inherit version history automatically, all without changing how the agent actually behaves. So, after the agent generates output, we upsert that file into Box, so it becomes part of the same file system. All right, so now let's run this. We saw it do two things. First, the script uploads demo documents into a Box folder. Next, it also seeds a SQLite database with customer data and conversation history. Back in Box, we have the folder created by the seed script. These documents now support /docs in the virtual file system. And from the agent's perspective, these are just files. Now, we ask the agent to generate a personalized sales proposal. Under the hood, it's going to read from /docs, read from /memories, and write to /workspace. All right, looks like it's done. Let's go back to the very top. So we have our generated proposal right here. And if we go back to Box, we have the generated proposal uploaded into our folder. We have our version history preserved, and the agent didn't change. All we really did was replace the file system layer. All in all, file systems are becoming a practical abstraction for agent context. When you back that file system with Box, you get permission-aware access, collaboration, and governance without having to change your prompts or agent logic. If you want to try this out yourself, check out Box Community on GitHub. I'm Andrew, Senior Developer Advocate here at Box. See you next time.